Hey class, we are now on Unit 3 of our Biochemistry course and our topic is still on water. Are
So class, in
particularly
Unit
on
3.2, we
Unit
will jump at
3.2
pH
on
and skip
our
the differences of
pH.
acids and bases since you've already learned this in your high school and also in your prerequisite subject in organic chemistry. What is pH? Many of us know that pH is the measure of acidity or alkalinity of a solution. That is already enough for others to know, but for us in the medical field, we need to specifically know that it is the measure of the amount of hydrogen ions that are present in aqueous solutions. Hence, we term it portents of hydrogen or power of hydrogen, which came from Sorensen, the Danish chemist who introduced the concept of pH and invented our pH scale.
I just would like to share this meme from Facebook. I posted this on my Facebook timeline last peak of the pandemic because my mom is fighting me over the pH values of these foods when it became one of the myths that alkaline food can cure COVID. And like really, just because it is published in a journal, you want me to believe that dandelion has a pH of 22.7? So I love my mom, but she really got hooked on what she sees on social media and believes that more over someone who teaches chemistry. So this is a eye opener for everyone that you don't believe anything that you see on social media.
So we have this famous pH scale, another important tool in chemistry that runs from 0 to 14, where 7 here is neutral and those below 7 are acids and those above 7 are bases. Of course, the extreme values are strong ones, so you will see here that the battery is a strong acid and that the drain cleaner is a strong base. While those near the neutral value or pH 7 are weak acids or bases. So you will see here that the blood is a weak base and milk here is a weak acid. Take note that a change in one pH unit represents a tenfold change in the acidity of the solution. So for example, we have here pH 1 and the second solution is pH 2. The first solution is not twice as acidic as the second. It is actually 10 times more acidic than the second. What happens to acid or base when in contact with an aqueous solution? An acid here breaks apart and donates hydrogen ions, while our base here donates the hydroxide ions. So weak acids release hydrogen ions only partially, while strong acids dissociates completely and releases all hydrogen ions. The significance of this concept in our body is that we don't want complete dissociation or else everything else in our body will keep being reactive. On the right side, you will see examples of acids. So we have here weak acids, vinegar, acetic acid, and our oranges and lemon or citric acid. We have also strong acids here. What is the acid in our stomach? That's hydrochloric acid. Yes, and what is the acid found in car batteries? Yes, that would be sulfuric acid. So let's look at the relevance of these acids in our body. In our body, many processes require acids to maintain them. So can you think of acids that are found in our body? What do these acids do in our body? So let's start with the strong acid that is found in our body, our hydrochloric acid. What does this do? So hydrochloric acid is produced in our stomach and it assists with digestion. Another is fatty acids. So these fatty acids, you will encounter this when we go to lipids, but this is are released when the body breaks down fats for energy. Another one, we have amino acids. So in unit 5, we will be talking about amino acids and proteins. So we know that these are the building blocks of proteins. We also have in our unit 4 nucleic acids. So these are responsible for our genetic makeup. So now you know that these acids donate hydrogen ions or release hydrogen ions when it comes in contact with an aqueous solution. How do we calculate pH? To calculate pH, the formula is simply pH is equal to negative log of the hydronium ion concentration. So it looks complicated, but it is not. If you have the hydronium ion concentration, you can easily compute for the pH. Square brackets around the hydronium means that you are using the concentration of hydronium ions in the solution being measured. The next step is figuring out how to use your calculator to solve problems using logarithmic relationship. Remember that each calculator will have its own order of button pushing. So now you must learn to use your calculator. Try it in your calculators. Input negative log 1 times 10 raised to negative 7 and find out what the pH is. So this is hard to do. Turn on. So we put negative log of 1 times 10 raised to negative 7, and that would give me, okay, perfect, 7. So you can also try to put the value 10 raised to negative 2. So we just change this value to 2 and then see, oops, equals, so you see that pH is equal to 2. So do you see the trend? Therefore, if you have pH is equal to negative log of 1 times 10 raised to negative 13, I'll be expecting that my pH is equal to 13. Therefore, we say that pH is equal to, we can use the 10 raised to negative pH. But of course, pH problems won't look like this. That is why it is a problem. So we go to the next slide. So let's look at the problem given in your activity. What is the pH of a 0.00010 molar solution of nitric acid, a strong acid? Because the problem told you that nitric acid is a strong acid, you know that it dissociates nearly 100%. So you know that the hydronium ion concentration will be equal to 0.00010 molar or 1 times 10 raised to negative 4. So this will be an easy one already for you. You will need your calculator again. Just plug in the values to your formula. pH is equal to negative log the hydronium ion concentration. So you already have the hydronium ion concentration. So you will put negative log of 1 times 10 raised to negative 4, and this will give you 4. Or if we use our trend a while ago, you will see that the pH, 10 raised to negative pH, the pH is already here, 4. So what if you are asked to calculate pH for basic solutions? So there are several ways to compute this. I will be giving two ways, and in this slide, we will connect pH and pOH. So if pH is the negative logarithm of the hydronium ion concentration, pOH is the negative logarithm of the hydroxide ion concentration. Why then do we use pH to measure a base on a pH scale? Remember that we have only a pH scale. We don't have a pOH scale. But there is no need for that because we convert pOH into pH because of this relationship between the two values. So pH plus pOH is equal to 14. So you will see here if the pH is 0, pOH here is 14. If the pH is 4, pOH here is 10. If the pH is 7, pOH here is also 7.
So this is a similar problem as we had a while ago, but we are having a strong base, potassium hydroxide. So meaning they still completely dissociate, and you are asked for pH given your strong base, or you will be computing for your pOH. So given this formula, pOH is equal to negative log 10 of your hydroxide ion concentration. So negative log 10, 0.00010 molar solution, or negative log 10. This is 1, 2, 3, 4. 1 times 10 raised to negative 4 m. Same solution. When you plug this on your calculators, it will give you 4. That means your pOH is equal to 4. But your question is asking for your pH. So for your pH, since pH plus pOH is equal to 14, we will plug your pOH here. 4 is equal to 14 plus pH. Therefore, your pH would be 10. 10 plus 4 is equal to 14. So that makes it a base or basic. It's a 10.
So the next way is using auto-ionization constant of water using the formula hydronium ion concentration times hydroxide ion concentration is equal to our 1 times 10 raised to negative 14. So therefore, if you are given a hydronium ion concentration, for example, you can compute for the hydroxide ion concentration. And if you are given the hydroxide ion concentration, you can also get the hydronium ion concentration. So if you have this hydronium ion concentration already, you can use our first formula for pH, which is pH is equal to negative log of the hydronium ion concentration to get the pH of the solution. So let us try these methods in one item in your activity for Unit 3. What is the pH of a 0.0136 molar solution of potassium hydroxide, a strong base? Again, because you were told that the potassium hydroxide is a strong base, you know it dissociates nearly to form 1.36 times 10 raised to negative 2 hydroxide ion concentration. So using method 1, we will use this formula first. POH is equal to negative log of the hydroxide ion concentration, which is already here. And we will just input that. That gives me 1.866 after putting that in the calculator. Then we make use of the next formula, pH plus POH is equal to 14. And we are looking for pH, but we already have the value for POH, which is 1.866. Therefore, pH is equal to 14 less 1.866, and that gives us so let us try the other method. So if you remember the auto-ionization constant of water, we have this formula, and you can figure out the hydronium ion concentration from this one, given the hydroxide ion concentration. So we will use hydronium ion concentration is equal to the auto-ionization constant of water all over the hydroxide ion concentration. And since this has a value 1 times 10 raised to negative 14, and this has the value of 1.36 times 10 raised to negative 2, we will have the value of hydronium ion concentration, which is 7.35 times 10 raised to negative 13. So now that we know the hydronium ion concentration, we can easily figure out the pH using this formula that we have. pH is equal to negative log of the hydronium ion concentration. So that is negative log of 7.35 times 10 raised to negative 13, which gives us 12.13. So if you go back to the next slide, we also got the same value. So you can use either method depending on which one is more easy for you. So what if you are not given concentrations, but rather you are given the pH itself, and you are asked to compute for the concentration of hydronium ion or the hydroxide ion? So remember the trend that we had in the previous slide, that pH is simply the exponent of the hydronium ion concentration. We could start with this trend. So we get another item from your activity for Unit 3, which is the given value is 5.05. So if your pH is 5.05, we just plug in it here, 10 raised to negative 5.05, so that we can get the value for the hydronium ion concentration. So this gives us the value 8.9 times 10 raised to negative 6 molar. So that is already our hydronium ion concentration. So what if we are asked to know the hydroxide ion concentration? So again, we can use any of the ways or the methods that we've learned. So for now, I will use the auto-ionization constant to find the hydroxide ion concentration. So manipulating the formula for the auto-ionization of water, we will have hydroxide ion concentration is equal to auto-ionization constant all over the concentration of the hydronium ion concentration. So that is, if we plug in the values, that is 1 times 10 raised to negative 14 all over, we will get this 8.9 times 10 raised to negative 6. And we will have the value 1.1 times 10 raised to negative 9 molar. So this will be our hydroxide ion concentration.
So for your activity 3.2.1, this is already easy for you to solve since we've already have samples of this. For your activity 3.2.2, you still need to read what equivalent base would mean before you can actually totally solve this one. You will see here that the given acids are not strong acids compared to our examples a while ago, but weak acids. So what have we learned from this unit 3.2? First, what is pH? Second, what is the importance of pH in our body? And third is how is pH calculated?